first thing is you have homework for me. Streamers, listen to me a second. If you get booted out of WebEx here anytime during the class, like all of a sudden it just terminates your meeting, give it a few minutes and log back in, please. I'm not saying that's going to happen, just giving you a possibility. So where we left off last Thursday is we were talking about sampling. We talked about, I'm going to kind of give you a little heads up what we were talking about. We had good sampling designs. Okay? That's where we're at here. Remember, the sampling design is how you go about choosing your sample. I've got 3 of them up till now. The first one is your SRS. Remember, that's short for simple random sample. That's where you put names in a hat. That's where we give everybody in the population a label, right? Every label has the same number of digits. You're running the table A. Somebody's giving you a line number, and you're reading table A however you need to read it. The second one we talked about is stratified random sample. And you know you're looking at a stratified random sample as soon as you start putting your population, before you choose anybody, before you start doing any kind of random choosing here, the first thing you do is you divide your population up into what I called similar groups, right? Strata. And then you sampled each one of the groups and you put them together to combine them. I gave you an example about what? Doing like freshmen, sophomores, juniors, and seniors. We did the one about sampling at a party, right, out of the homework. That's stratified. You know, one more time, you know you're looking at a stratified random sample is they tell you they want to take a sample, and the first thing they do is, okay, take that group of the population, that group, however many groups it is, right? It might be 2, 3, 4, and then they sample within each one. The third one that I had sent you to look at, and I talked a little bit about, is a systematic random sample. And I never did pick one, but I gave you a couple thoughts about how a systematic random sample works. I gave you the little thing about quality control, right? We're going to pick every 10th, whatever product you're making off of the assembly line. You'll pick every 8th car off the tear apart to see it if you're manufacturing cars, right? Maybe did I give you the Twinkie one? Yeah. We pick every 12th Twinkie, right, to sample. That's systematic random sample where somewhere you choose a number at random. Right? And you're going to not choose a number like between 0 and 100, or between 1 and 100. You're going to choose a number between like 1 and 20. Let's say you choose 11. So whatever you're doing, you're going to choose the 11th one down the road. So you'll choose number 11, 22, 33, so on. That's a systematic random sample. All right? There's a fourth one. This is where we're starting new here. And the fourth one is multi-stage sample. Now notice the word random, that's the only one the word random doesn't show up in, the fact that we're using chance. But we're going to use chance here. Okay? Here's the way I want to do this. I'm going to give you an example. I'm going to give you my own. All right? Because usually when you start seeing a multi-stage sample, that's when you're trying to sample something like households in the United States where they're all over the place, right? So let's do this. Let's say I want a sample of 1,000 households. That's what I want to end up with. All right? A sample. In other words, my end's 1,000 here. When I'm done, I want 1,000 households here. Okay? So when I think about multi-stage, we're going to do this more than one step, right? More than one stage. So my first thing to do would be step 1, or let me call it stage 1. Now, at every stage, we're going to use something we already know, whether it's a systematic random sample, stratified, SRS, right? Now, if I'm going to choose 1,000 households, I like to have 1,000 households from different areas of the United States, right? So let's do this. Let's say we divide the states into 4 regions. And my 4 regions would be the ones I think about: east, west, south, and north. All right? So what I'd have to do is I'd have to take the 50 states and decide on what region it is in. Right? So I just divided your states into 4 regions, okay? Just so that I get coverage everywhere, I'm going to choose 2 states from each region. So there'll be 2 out of the east, 2 out of the west, 2 out of the south, 2 out of the north. What did I just do? What kind of sampling is that? What was the first thing I did? I divided the population into, that's a stratified random sample I just did, yes? I divided the states into 4 regions, and then what did I do? I took an SRS of 2 of them out of each one of the regions. That's a stratified random sample right there, right? So at this point, that's stage 1. And so does everybody understand at this point what you have is you've got 8 states, right? 2 out of each region, okay? So the multi-stage part comes in, stage 2. Let's choose an SRS of 50 cities out of the 8 states. See, here's the catch. Is at stage 1, you chose 8 states. Yes, it was a stratified random sample. We did that. Yes, there was 2 in each region. You had 8 states. Now, within those 8 states, I want to choose 50 cities, right? So the other 42 states are gone. You're not choosing any cities out of the other 42. You're choosing your 50 cities out of the 8 states from step 1, from stage 1. Okay? Stage 3. Now you're looking at these 50 cities. Let's choose 100. Let's make it an SRS. Let's choose an SRS of 100 streets in the 50 cities. I got 8 states. I chose 50 cities out of those 8 states. I got 50 cities. I chose 100 streets there. Yeah? Now, if I've got 100 streets, is it possible for me to choose 1,000 households off those 100 streets? And the answer is yeah. Stage 4. Choose an SRS. Of 1,000 households on the 100 streets. There's my sample. Now, here's the way I think about it. Yes, it's multi-stage. I wrote stage 1, 2, 3, and 4. What I think about it's like a funnel, right? And we're always funneling down. And the next stage down is coming from the stage above, right? I started with all the states. I chose 8 of them. Inside of those 8 states, I chose 50 cities. Inside of those 50 cities, I chose 100 streets. Inside those 100 streets, I chose 1,000 households. Now, let me ask you this. Does this give every household a chance of being selected? Is every household on some street got some street number? Is every street in some city? Is every city in some state? Is every state in some region? And the answer, yeah. Every household has a shot at being selected here. Yep. Okay? What's the advantage of this? Well, this is time and money here. What's the worst thing that happens? You got to send people to 8 states, right? Yeah? You got to send people to 50 cities within those 8 states. We've cut down, right? It's not like we're going to have 1,000 and go to 1,000 different cities and 1,000 different streets. Yes? We've cut it down. So we got less time and less money here. That's multi-stage. I mean, I can make this thing as many stages as you want here on how much we want to pick down to do it, right? That's multi-stage. That is random. Because at every stage, what am I doing? Stage 4, I chose an SRS. Stage 3, I chose an SRS. Stage 2 was an SRS. Stage 1 was a stratified random sample. At any stage, it can be a stratified random sample, an SRS, one of our other sampling designs. Multi-stage, there's all kinds of randomness running around here with an SRS and stratified. It's like a funnel. Okay? That's your 4th good one. Now, when I say you got 4 good sampling designs, what I mean is they all use chance. The big term over top of these 4 would be called a probability sample. Probability sample is not a design. These 4 here are the design of a random sample. SRS, stratified, systematic, multi-stage. When I say probability sample to you, what that means is you're using chance to choose your sample. All 4 of these are probability samples. They give every individual in a population a chance of being selected. I think I actually wrote that down. We give everybody in the population a non-zero chance. That's the definition of what a probability sample is. It's not a sampling design. It's the definition over top of all these that we're using chance. Now, the rest of this chapter. Let's say we got a good sampling design. One of our 4 here. Right? One that should represent the population as best as we can do. All right? Can we still screw it up? And the answer is, yeah, of course. All right? So, I want you to think back to convenience sampling, voluntary response. What was wrong with them? They introduced bias, right? So, I'm thinking about other sources of bias. That means beyond taking the sample. That means beyond choosing your random sample. What can we do wrong here? I got about 4. 1 is undercoverage. Now, before I tell you what that undercoverage means, I got to give you a definition, all right? I could have gave it to you before, but it always comes to my mind at this point here when we're talking about undercoverage. Sampling frame. Right? When somebody's talking to you about the sampling frame, what they're talking about is the sampling frame is the list of the population that is used to choose the sample. I don't care what good sampling design you're using. Somewhere you got to have a list in your hand of your population. Yes? That list that you have, that you are using of the population that you use to choose a sample, that's called the sampling frame. Well, your sample suffers from undercoverage when what? An incomplete sampling frame. What that means is you do not have an accurate list of the population. You are missing groups of the population on your sampling frame. If you do this, your sample is going to suffer from undercoverage. Didn't I just give you a homework problem that said that? I'm back here on page 221, I think. 824. A sample in households in a community is selected at random from the telephone directory. Your sampling frame is the telephone directory, right? That is the list of the population that you are using, the telephone directory. In this community, 4% of households have no phones. Those households aren't in the telephone directory. 10% have only cell phones. Those 10% aren't in there. And another 25% have unlisted numbers. So all those phones, 25%, 10%, and 4% are not on your list, right? They're not in the telephone directory. This sample will certainly suffer from undercoverage, right? Because your sampling frame, the telephone directory, does not have every household listed. Unlisted numbers, cell phones, no phones, right? You're missing folks. You're leaving out groups of the population. Now, why is this a big deal? The problem is, when I look at this, it looks like 25, 10, and 4. I mean, you're looking at 39% of the population that's not going to be in your sampling frame, yeah? When I start seeing undercoverage where you're leaving out 40% of the population, you understand why that's a source of bias? Look, I don't know. Okay, so you leave that group out and you get your results. I don't know if these 40% had a chance of being in your sample, would that change the results? There's enough to change the results, right? Or would they confirm it? I don't know. It's a source of bias, right? You don't know what they would answer, whatever questions you're looking at there. Okay? That's number one. Number two, and I was just guilty of this yesterday. Number two is non-response. You know when those people call your phone at dinner time? And you pick the phone up and the guy wants to survey you and you go, look, dude, you just called me at dinner time. Click. That's non-response. Do I need to write a definition down of non-response? That means you do not respond to the questions, right? They don't get your answers. Whether you hung up on them, whether they sent you the questionnaire in the mail, right? And you just wad it up and throw it in the garbage, that's non-response. That counts against you. You'll see some homework problems where non-response is up to like 50%. Oh, dear God. Only 50% of your sample actually answered the question and you're telling me everything's okay? What's this other 50% think that you never got an answer from them? That's a problem. The other thing about non-response is a lot of people will tell you the sampling frame. They'll tell you about the undercoverage. People won't report non-response to you. They won't tell you, we tried to contact 2,000 registered voters and we got 50% non-response. They ain't going to give you that on the little poll and write things like that for you. Why? Because if 50% of the people you tried to get to be in your sample didn't answer, well, I don't care what the other 50% said. Right? That's a problem. Non-response is a problem. Third one. Yeah, I'm bad about this one too. I'm real bad about non-response. And actually, I just did that to a guy last night. He called me, and all I could tell him was, dude, you just called me at dinner time. I appreciate your call, but I can't help you. My wife looked at me like, you really did that? Yeah, I did that. I could have gave him number 3. Number 3 is response bias. Now, the only thing I'm going to put here is when you actually get the people to talk to you, whether you send them the survey or you call them on the phone or whatever you do, you would like truthful answers. You would like their truthful answer to the question they're asking you. Now, here's my thought. This comes in 2 ways. One is, you start asking me about something illegal and I'm going to start lying to you as fast as I can lie. Mr. Marks, did you wear your seatbelt on the way to work today? Yes, I did. Yeah, you asked me something about it, I'm going to tell you exactly what you want to hear, right? That's not a truthful answer, right? 2, don't start asking me at my age something that I did 6 months ago. When was the last time you went to the doctor? Was that last week? Was that last month? Was that 3? When was the last time you went to the eye doctor? I don't know. Was that a year or two? Hell, I don't know, right? So now I'm not even trying to lie to you. It's just you're asking me something that happened in the past. One of the examples, one of the homework problems asks you, how many movies did you see in the last year? Shit, I don't know. 2, 7, what? Don't ask me something that happened in the past. People aren't trying to be dishonest with you. It's just you're trying to get me to remember something from the past, and it's just not going to happen. All right? So response bias comes in 2 flavors. I outright lie to you. Or you ask me something in the past, and I'm trying to remember when it was, and that probably won't happen either too good. All right? 4th one. Now, out of all these, undercoverage seems like a reasonable thing because in case you don't know, when you're trying to get a population that's rather large, it would be really hard to find a complete sampling frame. So you're always going to have a little bit of undercoverage. Non-response, you're always going to have to deal with that. You know, when the United States government does the census, right? You know, when they send the thing to the house, right? I understand it's a census. They're trying to collect information on every household. I got that part. It's not a sample. But the census actually suffers from undercoverage, right? Not everybody lives in a household. Homeless, all those. You're not getting information on them. They suffer from non-response, even as hard as they try because, yeah, I'm guilty of this one too. You know, they send you the census. You know when you throw that shit away, that's illegal. Oh, well, in case you don't know, when you throw that shit away, it's illegal. They can fine you. Then they'll send, you know, they actually send people to the house. They call, yeah, they do all that. Why? They're trying to take care of non-response, right? Because they know that's a problem. Even with the United States government, with all the time and all the money our money that they have, they still suffer from non-response on the census. Okay? Response bias. I didn't see anything on the census I needed to lie about. They didn't ask me anything illegal or anything in the past, so I could answer straight up. Okay? The 4th one is the one that always freaks me out here at this point. You wouldn't think this would be a problem, but then you got to stop and think about who's asking you the questions and what they want to hear you say. The wording of the questions. Like I said, you wouldn't think this would be a problem. Surely we have some good wording of the questions here. Oh, yeah, we're going to have to take a look at it. The dude's changed the examples that's in my head. And I'm on page 215. And it says, what was that question? I'm looking at example 8.8 on how the wording will have an influence on your answer here to a question. How do Americans feel about illegal immigrants? Should illegal immigrants be prosecuted and deported for being in the United States illegally, or shouldn't they? Ask this question in an opinion poll, 69% favored deportation. Yeah, not a shock. Illegal immigrants. But when the very same sample was asked whether illegal immigrants who have worked in the United States for 2 years should be given a chance to keep their jobs and eventually apply for legal status, 62% said they should. Huh. Different questions have quite different impressions of attitudes toward illegal immigrants. I always no, my other one's still here. What about government help for the poor? How do you feel about that? I feel good. How do you feel about welfare? I don't feel so good about welfare. Isn't it the same thing? Yeah, it's the same thing. Right? Throw the word welfare in, you get people against it all the time. I want to help the poor? Oh, everybody wants to help the poor. Right? So changing one word, I can change on what your response is. Yeah? I got another one for you. Suppose I told you that, 73% of the trash that goes into landfills is disposable diapers and plastics. How do you feel about those disposable plastic diapers? Well, I don't feel good. Hell, they make up 73% of the landfill. Right? I'm leading you, right? The questions lead you. Maybe one word triggers it, like welfare and poor, illegal immigrants versus ones that have worked here. Or I'm leading you to an answer by giving you some information up front on before the question, right? Wording of the questions makes a difference. Now, I'm going to give you the bottom line here, and I'm done with this, all right? The bottom line is this, is we would like to trust the information that we are getting from these samples, okay? So, you cannot trust the results. And to be honest with you, I'm not really thinking about any results. I'm just thinking about the information that you're getting of a sample survey So what that means is we've done some kind of sample, right, and we've asked them questions and we've got results from that, we've got information from that, until you know a few things here. One, the questions asked. Why am I worried about that? I'm worried about, did you lead them? Did you have poor wording? Is the question held just confusing, and I don't know whether I should answer yes or no just because your question was so bad. 2, how the sample was chosen. And all I'm going to put here, and I'm going to put it in blue, what I'm looking for is, I don't really believe when you start reading stuff, somebody's going to tell you they did a stratified random sample multi-stage. You're going to see the term random in there. We did a random sample. That means they used chance. We'll trust that. That's what we're looking for here. 3, amount of non-response. Sometimes they'll give you a count of the number of individuals that didn't respond. Sometimes they'll give you the percentage that didn't respond, right? We know non-response is a source of bias here. And finally, one that we never talked about. Look, we've talked about those 3, the questions, how the sample was chosen. We want to see a good sampling design. We want to see the word random. The amount of non-response, we talked about that. The 4th one is, and like I said, we never talked anything about that, is the date of the survey. Now, why is that important? You don't want to draw conclusions today from data or information that came from 10 years ago, right? We want recent, we want current info, as close as we can get. Like I said, I don't want to know what people think about anything from 10 years ago and try to apply it today. Hell, I don't want anything from 2 years ago and try to apply it today, right? I want its most recent information, most recent current data as I can get. Okay? I'm not overly enthused about the impact of technology here. That's the last little section here in this chapter. You can take a look at it. I mean, here's the way technology is going to... We don't have to go to your house anymore. We can call you on the phone. We can send you an email. But the problem with email addresses is, look, they can randomly generate phone numbers. They must be doing that now because I didn't think they was allowed to call me and ask me questions and stuff on my cell phone. That doesn't happen these days because they just got a random number generator. Hell, they'll just generate random numbers and call. The problem with doing it through emails, they can't generate random emails, right? Like you can generate a random phone number. You can't generate a random email to send to everybody, to people, okay? The email addresses is what I mean. So, those kind of things are going to cause confusion when they're doing calling phones or emails. That's why you see that crazy stuff about go to this website and vote, voluntary response. My other warning is this: there's always going to be some amount of undercoverage. There's always going to be some amount of non-response. There's always going to be some amount of response bias. Surely there shouldn't be any problems with the questions. People should be able to ask direct questions, right? We try to minimize as much as that as we can. Non-response, we try to get them, call back, send another questionnaire. Undercoverage, you try to get the most complete list of the population you can. You try to get the most complete sampling frame that you can. One other thing is I never mentioned, you do know that the length of the survey makes a difference. 10 questions compared to 40. Did you know the order of the questions make a difference sometimes? Yeah, all that stuff has to be considered here. But we don't trust anything until we know these things here, right? The date, non-response, how the sample was chosen. We're looking for random. And then we want to know the questions it was asked so that we can make sure you didn't lead anybody, you didn't give them any information on the question, all that, okay? To me, that's the end of that section. Now I'm going to tell you one more time. There's two bad sampling designs we talked about. Convenient sample, sampling the easiest to reach. It's like standing out in front of the library and taking the first 10 that come to you. Voluntary response, you give me a call-in poll, go to this internet site and poll. When people volunteer their response, when they choose themselves for the sample, those aren't good, right? The four we like are simple random sample, names and a hat. Give everybody a label. Go to table A. Stratified random sample, make similar groups. Choose each group. Choose within each group. We like systematic. Choose so many down the line in your population and stick with that number, whether it's 10, 12, 4, whatever it is. Multistage, funnel. Start out with everybody, funnel down until you eventually get the sample that you was looking for, whatever it was, like the households I showed you. All right? And then don't forget my other four sources of bias. Under coverage, non-response, response bias. What was the last one? The wording of the questions. That's what's in it. Okay? That's producing data through sampling. That takes us to the next chapter. Producing data still, right? Chapters 8 and 9 go together. Chapter 9 is still producing data, except this time it's experiments. Now, I'd warned you about Chapter 9 at the end of Chapter 5, where we're looking for this cause and effect, causation. We're looking to see if you make changes in your explanatory variable, will that actually cause a change in your response? That's what experiments is going to deliver to us. It's going to be a way for us to find if we have evidence of cause and effect, causation. Now, right at the bottom, right here, I'm looking at the first thing. It says, a sample survey aims to gather information about a population without disturbing the population in the process. Translation? When they're talking about a sample survey like what we were looking at in the previous chapter, that just means you're going to choose a sample, you're going to have these people, and you're going to ask them questions. You're not trying to influence their responses. We're just trying to get back truthful answers, right? That's what a sample survey does. Sample surveys are one kind of observational study. There's two things here, folks. There's an observational study where you just observe your sample, try to gather information, try not to influence them in any way. The other one is other observational studies observe the behavior of animals in the wild or the interactions between teachers and students in the classroom. This chapter is about the statistical design for experiments, a quite different means of producing data. Look, there's observational studies. You just observe. You just collect information, right? We just collect data. We just get them to answer questions. And then there's this little guy over here called an experiment, all right? Now, here's what I'm thinking. I want to go to page 228. And I want to think about the difference between an observational study versus an experiment. Now, the reason I take you to page 228, there's a box there. Two definitions, what an observational study is and what an experiment is. An observational study observes individuals and measures variables of interest. Whatever the variables are that we are interested in, we just measure them, right? But does not attempt to influence their responses. The purpose of an observational study is to describe some group or situation. It's to collect information on some group or some situation. That's it. The key word there is you just observe them. Measure whatever variables you're interested in. You don't try to influence their answers or what you are seeing. Okay? That's observational. Hence, you observe. The second one is, an experiment, on the other hand, deliberately imposes some treatment on individuals to observe their responses. Like, maybe we want to know, does aspirin reduce the risk of heart attack? Right? That calls for an experiment. No observational study is going to answer that kind of question. Maybe we want to know if the number of beers you drink influences or changes your blood alcohol level. No observational study is going to do that for you. That calls for an experiment. All right? My thought is this. The reason we're doing this chapter is because we're looking for causation. We're looking for cause, effect. An observational study will not help you with that. It will not help you with causation. They're the same thing, right? I'm just giving you my language. If you want more language, what we want to know is, do changes in the explanatory variable cause changes in the explanatory variable, cause changes in the response variable. All three of those things I have there in parentheses are all the same thing. When somebody's talking to you about causation, they're asking you to see cause and effect. They're telling you, what they're asking you is, do changes in the explanatory variable actually cause a change in the response variable? That's what we're interested in, this idea of making changes in this one will cause a change in this one. All right? So you look at example 9.1, right? And I want to look at that before we get too far into this idea of, how do we do an experiment? There's nothing to be done here with an observational study. You just choose your sample, or you go out and choose whatever sample it is and collect and measure the variables you're interested in. An experiment actually takes some detail. You've had a chemistry class. Take detail to do an experiment. Biology class, it takes detail to do an experiment. What are you looking for in a biology class or a chemistry class with an experiment? You're looking for cause and effect, right? Making changes here causes changes there. Same thing here. All right? Now, example 9.1, it says, does playing video games improve surgical skills? Oh, dear God. I hope it does, because the young ones today get a lot of practice. I'm thinking all that shit there, man. You're probably good with the knife, right? I'm hoping it helps. I'm feeling like I'm getting closer. In laparoscopic surgery, a video camera and several thin instruments are inserted into the patient's abdominal cavity. Ooh. The surgeon uses the image from the video camera positioned inside the patient's body to perform the procedure, manipulating the instruments that have been inserted. Because of the similarity in many of the skills involved in video games and laparoscopic surgery, it was hypothesized that surgeons with greater prior video game experience might acquire the skills required in laparoscopic surgery more easily. Sounds like a hell of an idea. 33 surgeons participated in the study and were classified into three groups. Never used 3 hours per day, and more than 3 hours per day, depending on the number of hours they played video games at the height of their video game use. I'm assuming this is not all at the same time. I'm assuming they played the video games before they were actually surgeons. The hell, they might play the video games while they're surgeons. I don't know. Okay? It was found that those with more video game playing did better in a simulator program measuring laparoscopic skills. Observational study. Now, you see they put that in parentheses? This is not an experiment. Nothing was imposed, right? This is an observational study. I wanted to point that out to you. Therefore, causality cannot be definitely determined. Now, what they mean is, from their observational study, what they've seen is, right, what the data is showing them from their observational study is that the surgeons who had more video playing experience did better with the skills for this laparoscopic surgery, right? That's what they saw. That's what they told me. That's an observational study, okay? Now, it was found that those with more video playing did better in the simulator program measuring laparoscopic skills. However, in their conclusions, the authors correctly pointed out this is a correlational observational study, and therefore causality cannot be definitely determined. Although the data showed a clear association between prior video game experience and improved scores in the simulator program, we cannot conclude that video game playing caused the improvement. Now, does anybody remember the story about lurking variables? Yeah, well, here they come. Okay? It says, people who play more video games may be different from those who don't. in terms of both their interest and the natural skills that are required in video games. Those who played more video games may have scored better simply because they have more ability in areas such as fine motor skills, hand-eye coordination, depth perception. You know what those guys right there are? Those are your lurking variables, right? Okay? It's that are required in both video games and laparoscopic surgery. Now, here's the thing. This is what I want you to take out of this. I don't care about the fact that we're playing video games and doing laparoscopic surgery skills. What I care about is this. You're never going to give me cause and effect from an observational study. Why? There's always these lurking variables that will be a problem. See, we cannot say that the video skills is what caused them to have better surgical skills. It could have been these other lurking variables that actually caused that, right? You can't say from an observational study, well, that thing you were looking at actually caused them to have better skills, right? You have to do an experiment if you want to see cause and effect. Now, I'm not going to read this next part here. Here's what we'd have to do, okay? For me to turn this into an experiment, okay, we got to find like 50 surgeons that are willing to participate in your experiment. I need to randomly select 25 for this group, and actually here I'm going to do 3 groups. So I want 75 surgeons. I need to choose randomly 25 here, 25 more here, 25 more here, right? I choose the groups. In other words, think about it like this. I got 75 surgeons. Number them 0, 1 through 75. Go to table A, put the first 25 numbers that come up that you have labels for in the first group, the next 25 in the second group, and the last 25 in the third group. Did I randomly select my groups? Now, this group here is never going to play video games. This group here is going to play up to 3 hours. This one here is going to play more than 3 hours. I'm imposing the amount of video game playing that they are going to do. Right? After we do this for 5 years, I didn't say we could always do it. I'm telling you how this has to be set up, right? After we do this for 5 years, then we test them, right? We do this little simulator and see which group does better. Yeah? Do I have a problem with the lurking variables now? What I mean is, this was no video games, up to 3 hours, more than 3 hours, right? Let's say this group does much better on the simulator skills. Why is that? Is it because they had better depth perception, fine motor skills, hand-eye coordination? No. There's ones in all those groups that have those, correct? We spread them out. They didn't get to pick what they did. We gave them what they were going to do. We imposed this treatment of how much video game experience you're going to have, right? So at the end, I don't have a problem with lurking variables because they're all working on all the groups, right? There's some in here that have good fine motor skills, hand-eye coordination, depth perception. There's those people's in this group. Those people are in that group too, right? I mean, I chose the groups. Okay? So at the end, if one of the group does better than the other two, what caused it? It had to be the treatment that you imposed. It can't be one of the lurking variables. You have taken care of that. You have controlled the lurking variables by not letting the individuals pick which group they're in. You chose for them. Does that make any sense to anybody anywhere? See, that's the whole thing about an experiment. And the key word is to control the lurking variables. So when I'm done here and there is something going on between the groups, like one is way better than the other, then I know it's not because of a lurking variable. Because it might be, when they did an observational study, the people that had good depth perception, what was the other things? Hand-eye coordination, fine motor skills, they might really love video games to start with. So hell, they play their ass off, right? They play more than 3 hours. Well, of course they're going to do it on the simulator because they got the other things also, right? The people that don't have any fine motor skills, don't have any freaking hand-eye coordination or depth perception, do I want to play a video game? No, I'm not going to be any good at it, right? Those people will be, when I do an experiment, they'll be in all the groups. You'll have different types of people in all of them. The only difference between the 3 groups, not those lurking variables, because they're working on all of them. The only difference between this group, and this group is the amount of time they spent playing video games per day. That's it. This is how you get cause and effect, folks. okay, is you control the lurking variables. This is what an experiment does. Now, if you understand what I just did, the rest of the chapter is just language and how in the hell do I write this down and how do I outline it and how do we set everything up. But that's the idea, is they don't get to pick what they want to do. You impose it on them. That's how you know you're looking at an experiment. When we start imposing how much video game you're going to play, that's an experiment. You're taking care of, one more time, you're controlling the lurking variables. Okay? Now, does everybody see on page 229? I got to write this word up because the word here is confounding. We talk about variables being confounded. This is a problem with an observational study. This is the reason we can never show cause and effect, because the variables are always confounded. You can't tell me what's causing the effect that you're seeing, right? So, two variables. It could be more than two. Hell, it could be two or more variables, right? And these are explanatory variables or lurking variables. You know, the ones we didn't even bother to measure, like depth perception, hand-eye coordination, fine motor skills, are confounded. That's the magic word here. When their effects on a response variable, right, the thing that you measure at the end, the variable you measure when it's all over with, okay, cannot be distinguished from each other. Okay. We go back to the video game skills, playing video games and surgical skills. See, the amount of video games that they play per day, right, is confounded with their fine motor skills, their hand-eye coordination, their depth perception. One of them was the explanatory variable, the other three were lurking variables. An observational, maybe I need to write this down for you. An observational study always suffers from confounding when you're trying to use it for cause and effect. Right? Observational studies always suffer from confounding. The reason I wrote that down is you got to have that stuck in your head. Look, nobody's ever going to use an observational study to show you cause and effect, right? That an observational study always has this problem, right? It's always going to suffer from confounding. You're not going to know what caused the effect that you think you saw there. You're not going to know whether it's an explanatory variable or one of many lurking variables that could be there. Okay? Experiments are set up to control the lurking variables, to control the confounding. All right? Now, look, that's the deal. Observational studies, are they a good source of information? Yeah. Are they a good source of data? Yeah. Can I use them to show cause and effect? No. Can I use them to show causation? No. Why? It's this right. It's on this page. Confounding. I don't know what's causing the effect that you're seeing. Okay? So, when I think about an experiment, okay, what I'm always looking for is the following. I'm always thinking about we impose a treatment. Not self-imposed, we impose. That's the magic thing for me is, oh, an experiment? Did you actually impose some condition on these individuals? Yeah? Oh, I'm thinking I'm seeing some kind of experiment here then. Okay? Remember, the purpose of an experiment I wrote on the first page there, we're looking for causation, we're looking for cause and effect. What I want to know is, if we make changes in an explanatory variable, does that actually cause a change in your response? Now, I'm on the bottom of page 230. There's some definitions here. Experiments have their own language. It's like everything else we do in this class. Every time I change a little bit of pages, I got definitions for you. And so there are subjects, factors, and treatments, and then I'm going to throw one more in there at you, all right? The individuals studied in an experiment are often called subjects, particularly when they are people. Okay, you've got one, individuals. If they're people, if they're human, we talk about subjects. Sometimes you'll hear me call, if we're doing it on dogs or cats or whatever, they're subjects, right? They're the individuals. Sometimes you'll actually hear me say the term experimental units. These are the people, objects that are having the treatments imposed upon them, right? Those are the ones being studied in the experiment. Individuals, subjects, experimental units. Okay? 2, factors. Nothing special here. It says, the explanatory variables in an experiment are often called factors. No, they're always called factors with us. So, the factors are, these are your explanatory variables. These are the ones that we're looking to make a change in. Why can't they just call them explanatory variables? Hell, I don't know. In experiments, they talk about factors. We don't talk about explanatory variables. They're the same thing. 3, a treatment. This is a specific condition imposed on the individuals. It says, it's a specific experimental condition applied to the subjects. If an experiment has more than one factor, a treatment is a combination of specific values of each factor. Yeah, look, I can get all kinds of stuff going on how many treatments there are in an experiment. All right? I want to add one to this. All right? There's a 4. And I want to talk about the level. And when I think about the level in an experiment, it's just the values or the value of the factor. And what I mean by that is, it's possible, and it's always going to be the case, that if you have a single factor, you have one explanatory variable, that variable is going to be given to the subjects in different levels. Right? So you could have one factor that has 2 levels. Right? So that's going to make 2 treatments, right? One for each level of that particular factor you're going to have. Okay? So the book doesn't give you level or it doesn't give you levels. That's just the value of the factor. I mean, think about it like this. I might have a pill for high blood pressure, right? I might want to give it at 10 milligrams. I might want to give it at 20 milligrams. There's one factor, right? The high blood pressure pill. How many levels are there? 10 milligrams and 20 milligrams. How many treatments are there? If you've got one factor and it's got 3 levels, how many treatments are there going to be? 3, yeah? Suppose I have 2 factors. This one has 2 levels, this one has 3. And I want to do all combinations of this factor with 2 levels, this factor with 3 levels. How many combinations are there? 2 times 3, which is 6, right? You compare each one of these with each one of these. Okay, so I can have a whole bunch of treatments show up here. Now, example 9.2. We might as well take a look at this because before we do anything and before we start laying out our own experiments, we need to be able to pick out, well, who's your individuals, who's your subjects, what's the factors, what's the treatment, what's the level there. All right? So, example 9.2, it says, do abandoned children placed in foster homes do better than similar children placed in an institution? The Bucharest Early Intervention Project found the answer is a clear yes. The subjects were 136 young children abandoned at birth and living in orphanages. Okay, so when I look at this example, 9.2, my subjects, 136 children. Yes, they were abandoned and living in orphanages, but my subjects here are 136 children that we have here. It says, half of the children chosen at random, they labeled them from 001 to 136. They chose, what's half of that? 68 of them with a simple random sample, put them in one group, and the 68 that was left over went in the other group, right? You had two groups here. That's what it's saying is, half of the children chosen at random were placed in foster homes. The other half remained in the orphanages. Okay? It says the experiment compares these two treatments. There's a single factor. So there's one factor. And I'm going to put it like this. The factor is type of care. Now be careful here. The factor is, like I said before, with the high blood pressure pill. It's whatever the high blood pressure pill is. How many levels do you have here? In other words, how many different types of care do you have? Levels was foster or institutional. So there's two levels. There's a single factor. How many treatments do you have? Two treatments. Foster care, institutional care. So that's all the definitions we just talked about. Your subjects were 136 children abandoned living in institutions, right? The factor is the type of care you're going to give them. The levels, you had two levels. There was two different types of care. There was foster and institutional. The treatments are, well, you gave them foster care, you gave them institutional care, right? One factor, two levels, gives me two treatments. Yep. Now, when an experiment, remember, that factor is your explanatory variable. It's the type of care, right? We wanted to change it. We want to do foster versus institutional. There's got to be something we measure after the fact. After you've imposed a treatment, there has to be a response variable or response variables. That term does not change. And it says, the response variables included measures of mental and physical development. So, I don't know what they were. I don't really care. But the response variable, in this case, was what did they measure? They measured mental and physical development with whatever test they used. When you're looking at an experiment, the response variable is whatever you measure after you have imposed the treatment. In this case, they did some kind of test of mental and physical development. Okay? That's everything there is to know about an experiment. Subjects, factor, levels, treatments, response variables. Now, I have to do 9.3, and then we'll go on to how to do this badly. But we've got to do 9.3 because right here, this experiment we're looking at here with these foster care and institutional care, that's a single factor experiment. Had two levels, but there's one factor, right? One explanatory variable. If you look at 9.3, okay, it says, what are the effects of repeated exposure to an advertising message? The answer may depend on both the length of the ad and how often it is repeated. An experiment investigated this question using undergraduate students as subjects. So the subjects, this time, are undergraduate students. It doesn't tell me how many. That's okay. If it doesn't tell me, I don't know. It doesn't tell me whether there's 100, 200. It just says, okay, the subjects were undergraduate students. Okay? It says all subjects viewed a 40-minute television program that included ads for a digital camera. Some subjects saw a 30-second commercial, others a 90-second version. The same commercial was either shown 1, 3, or 5 times during the program. Well, you have two factors this time. Right? There's two factors is length, repetitions. Okay? How many levels? I'm just picking this out so that I can tell you how many treatments there are. For length, how many levels were there? What does it show? 30 or 90 seconds, right? So 30 or 90. For repetitions, how many times was it repeated during this, 40-minute TV show? It was repeated 1, 3, 5 times, right? Those are the different levels for your different factors. So you've got length, 2 levels. You've got repetitions, 3 levels. Now, anybody know how many treatments we're going to have? Length was 2 levels. Repetitions is 3. This is a 2-factor experiment. You have 2 levels here, you have 3 levels here. You're going to end up with 6 treatments. Now, I'm not going to label them like I did last time. When I got this much stuff going on here, where you have 6 treatments, you got 2 factors, you got more than 1 level of each one of the factors, here's what I'm going to do. I'm going to draw you a little picture of what's going on here. Here is the length. It was either 30 or 90. Here is the repetitions. It was seen 1, 3, or 5 times. You'll see I got 6 boxes there, right? So one treatment's going to be right here. There's 1, 2, 3, 4, 5, 6. So if I look at the one that I got a little 4 in, what that group saw was they saw the commercial repeated 1 time and they saw it for 90 seconds. If I look at the one that's labeled with the 3, the treatment I would call treatment 3 there, they saw the commercial repeated 5 times, and each time they saw it for 30 seconds, right? So I'm reading, where am I at there? If I look at the one that's treatment number 6, they saw the commercial repeated 5 times, and they saw it for 90 seconds each one of the 5 times. That's all the possible combinations of the 2 lengths and the 3 repetitions right there. Now, there's got to be something these folks measured after the fact. Right? There's got to be a response variable here that you're looking at to see if you made changes to. So, 5. Look, I'm looking for this. It says the 6 combinations are in this figure. It's the same one I showed you there. After viewing, all subjects answer questions about the recall of the ad. Response variables. 1 is recall of the ad. Attitude toward the camera. I'm just going to write attitude. And then finally, intention to purchase. That's what they measured after they imposed the treatment. So again, here's another experiment. We've got the subjects. Those are the undergraduate students. You had 2 factors, right? The length and the repetitions. The length had 2 levels. The repetitions had 3 levels. Those 2 times those 3 gives me 6 treatments. And then what did they measure after the fact? Well, the recall of the ad, the attitude towards the camera, and their intention to purchase it. That's everything there is to know about this experiment here. I have a question for you. If I have 2 factors, right? And I have 3 levels here and 3 levels here, how many treatments am I going to have? Multiply, right? Because I'm going to match these 3 up with that one, these 3 up with that one, these 3 up with that one. I'm multiplying 3 times 3, there would be 9, right? And so I would just put another little row there in my box, and I'd have 9 different treatments. All the possible combinations of the levels of this factor and the levels of this factor. Now look, that's about as ugly as we get here in this class. It's give me more than one factor, let's say 2, with one having 2 or 3 levels and the other one having 2 or 3 levels. Right? So we got multiple treatments here. Now, advantages. Of an experiment. Over an observational study. One, we avoid confounding. That was the problem with an observational study. We assign subjects. 2, we control the environment of the subjects. What I mean is, we treat all subjects the same. They all have the same environment. Okay, I'm going to stop for a second. Here's my thought about this, all right? Let's say I'm trying to test a new dog food. Okay? And I want to test the new dog food versus the old dog food that has been on the market, all right? And so, I have like 30 dogs in their little cages. Yep. And so I label the cages 0, 1 through 30. I know I'm going to have 2 treatments, right? The old dog food and the new dog food, yeah? And I want to avoid any kind of confounding, because I want to assign the dogs to whichever food. I want to control the environment. What I mean by it is this. I'm going to label them 0, 1 through 30. I want you to simple random sample of 15. They're going to go in this group. The other 15 is going to go in this group. This group here is going to get the old diet, the old food. This one here is going to get the new food that we're looking to market. All right? What do I mean about control the environment of the subjects? Well, every day when I go in, I don't want to kick all these cages and not kick these. If I'm going to kick these cages, I want to kick these cages too. Right? You want everything to be the same. All I'm going to beg from you out of this is when we do this and we get these groups, the groups should be similar, correct? Because we did a random choice. I want the only difference between however many treatments you have, however many groups you have, is the actual treatment. No confounding, no lurking variables. We assigned the subjects. The environment, the subjects have been treated the same except for the treatment that has been imposed. Why am I so crazy about that? Why do I care so much about if I've got these 2 groups of dogs? Why do I care about the only difference between them is the actual food they're eating? What am I looking for here? Hell, I'm looking for cause and effect, right? I want to see if the new diet is better than the old one or worse than the old one. So anything else that gets in the way there will confound me at the end, right? There'll be a confounding problem. No, you're going to see me beg. You made these similar groups. You've done this random assignment. Please. The only difference between the groups is the actual treatments that they're receiving, because the reason we're doing this is we're hoping at the end that there is some difference between these groups. Well, if they've all been treated exactly the same and the only difference is the treatments, what had to cause that was the actual treatment. It's like washing out test tubes and stuff with a chemistry experiment, right? Everything has to be exactly the same. Same thing in the biology. I can see the little petri dishes where we're growing something here, we're growing something there. It has to be treated exactly the same. Same temperature, same light, all that shit. Why? Because whatever your treatments are, that's what you want to. That's what you're looking for the change in cause and effect from. Okay? Now, just like we did with sampling, we showed you the wrong way to do it. Yeah, we're going to start there too. Okay? So, here's the thing. How to not experiment. How's that? How to experiment badly. Now remember, my whole thought here is cause. That's the reason I wanted to do the experiment to start with. That's what I'm looking for, is cause and effect. 1, we want to impose a treatment. 2, we want to control everything else, other influences, lurking variables, environment, everything. This is what I was just screaming at you about. This is the right way to do it. Impose a treatment and control everything else. Control all the lurking variables, control the environment, everything. Only difference between groups are the treatments. This is the only way we can find evidence of cause and effect. That's what I was just screaming at you about too. Now, we take a look at example 9.4. This is a bad experiment. Yeah, they've imposed a treatment, I guess. Okay? It says, a college regularly offers a review course to prepare candidates for the Graduate Management Admissions Test, GMAT, which is required by most graduate business schools. This year, it offers only an online version of the course. So, it's just strictly online. There's no classroom, there's no videos, whatever. It's strictly online. The average GMAT score of the students in the online course is 10% higher than the long-time average for those who took the classroom review course. Is the online course more effective? What I'm asking you is, okay, they're asking you, are you seeing cause and effect here? They changed the format of the course. They went from a traditional classroom course to a strictly straight online course. And when they did that, the scores for the online course were 10% higher than the average over all the classroom courses from before. Did the online course actually do better? What I'm asking you is, are you looking at an experiment here? And the answer is no. Did anybody assign the people to the courses, or did they pick the course themselves? This looks like an observational study to me. The people picked to do the online course, right? Do you think the people that picked the online course might be different from the traditional classroom people? And the answer to that question will be, yeah, probably. Okay? So here's what it says. The experiment has a very simple design. I don't even feel like it's an experiment, but we'll go with it. A group of subjects, the students, were exposed to a treatment, the online course, and the outcome, GMAT, was observed. Okay. Now, we like to draw outlines of experiments. And so the outline here of what is going on is you had your students. They took the online course. And then we looked at their GMAT score. That's the outline. That's the one they have in the book. That's very, very simple. Is you have a group of subjects, you give them a treatment, and then you measure your response variable, right? The students are your subjects. Here are your subjects. Here is your treatment. Here is your response. That's what you measured after that. All right? Now, unfortunately, we can't draw any conclusions from this. To me, it looks like an observational study. We had some students. We observed that they all was taking the online course, and then we measured their GMAT score, right? You never controlled anything here. You didn't control any lurking variables. We didn't control anything, okay? It says a closer look at the GMAT review course showed that the students in the online course were quite different from the other students. You know what's coming now? As soon as they tell me that this group you're looking at is quite different, here comes the lurking variables. It says, from students who took in past years took the classroom course. In particular, they were older, more likely to be employed. An online course appeals to these mature people, but we can't compare their performance with that of undergraduates who previously dominated the course. The online course might even be less effective than the classroom version. The effect of the online versus in-class instruction is confounded with the effects of the lurking variable. This looks like an observational study, even though they're talking about an experiment. As you had students, they took the online course. You didn't impose anything. Hell, they chose, right? And then you measured a GMAT score as a response variable. It says, as a result of confounding, the experiment is biased in favor of the online course. Why? Because of the lurking variables. Hell, I don't know which way's better. Okay? Would the situation have been different if both the online and classroom course had been given this year? And the answer to that question is, yeah. You see this little move right here we just did? And I'm looking at this up here on the top, where you have subjects, you give them a treatment, or they volunteer for the treatment, and you measure something. You're never going to get cause and effect out of that. Suffers from confounding. Now, we're about done for today. I'm not quite done. I'm not quite there yet. We're going to start adding words to in front of experiment. See, the experiments we like to do in this class, we like randomized, comparative, experiments. That's what we like. Okay? We like to randomly assign subjects to treatments. That's the randomized part. Okay? That's the randomized. We want to randomly assign the subjects to the treatment. They don't get to choose. And then we like to compare treatments. That's the comparative part. Any experiment that we do in this class that is correctly designed and set up is randomized and comparative. We randomly assign the subjects to the treatment, and we always want to compare the treatments. The problem with the GMAT thing to start with is you didn't have anything to compare to. You only had one thing you was really interested in. One treatment you was really interested in was the online version, right? That's all you had. That's all you was interested in. We're going to have to come up with something to compare to. Okay? So, with that said, that we want to randomly assign subjects to treatments, always compare the treatments, we would take the students and we would do this. You know, the students taking the GMAT test at the end. One, I need two groups here, right? One, I need a classroom version. And I need an online version. I know all I'm interested in is the online version, but I need something to compare to. Okay? Now, you see this number 1 here? That has a name. Because you're only interested in the online version. That was all that was supposed to be offered. This is called a control group. It allows me to have something to compare to. Why is it a control? Why the word control? You are controlling the lurking variables now. Now you have more than one group to assign the students to, right? So I need to fix this experiment by introducing a classroom version. That classroom version is like, that's the norm, right? That's what's been going on for years. That's what you're comparing to, right? You're interested in the online version. So you have to have this control group. We will see you on Tuesday. Everybody be careful going to the house. We'll pick up there. I'll draw you an outline. And then there's a couple more things we need to look at here. All right? Be careful.
Hey, Professor Marks.
Hey.
I emailed you my homework, by the way. Just because I don't
somebody go ahead, hang on a second. You're going to get closer to the microphone. Somebody going to turn you up.
I was just going to tell you I emailed you my homework.
That's perfect, man. I appreciate it.
Okay, I was just going to let you know. Thanks.
Thanks, bud.